Hello everyone, in this video we will present our paper which is adversarial attacks against object detection that evade context consistency checks. First, let me briefly introduce myself. My name is Mingjun Yin. I'm currently a PhD student at University of California, Riverside. First, let's take a look at some background stuff. Deep neural networks has been shown to be vulnerable to adversarial examples, which are slightly perturbed input images, which lead deep neural networks to make wrong predictions. To protect from such examples, various defense strategies have been proposed. Among existing defense mechanisms, checking the intrinsic context consistencies within the input data has been recently shown to be very effective. The motivation of such kind of context consistency checkers is that given an image, there will always be a lot of information inside that images. Let's take a look at the example in the left-hand side. This is a benign image where a detector detects the stop sign and the intersection. If we try to misclassify the stop sign to a speed limit sign, however, a context-based adversarial defense mechanism is capable of detecting such that a speed limit sign occurred at an intersection, which is abnormal. To evade from such context consistency checkers, the intuitive way is to generate attacks using context consistency strategy. That is, we will perturb other objects as well. In this work, we select scheme as a defense mechanism to be evaded. Scheme is a context consistency checker. It detects attacks based on the context profile extracted from the intermediate layer of a faster RCN variant. It uses a bunch of autoencoders to measure the context consistency of a given objects. And we proposed our ADC frameworks to evade such kind of context consistency checkers. There are two attack goals in ADC. First is following the object detector. Second is bypassing the context inconsistency check. The first goal is achieved with the optimization problem defined as step 1, which perturbs the input image to make the object detector output the target classification labels. The second goal is achieved with two optimization problems defined in step 2 and step 3. In step 2, the context profile features are perturbed to make the attack detector output low anomaly scores. In step 3, the input image is further perturbed to output the target perturbed context profiles and the target classification labels. We evaluate the performance of our works on two datasets. We evaluate our frameworks in two scenarios. For white box attacks, we make assumption that the attackers know all the parameters, and for the gray box attacks, we assume that the attackers know the architecture and the training data distribution, but not the parameters. And we evaluate on three attack objectives. They are misclassification, hiding, and appearing. This is some evaluation results of our ADC framework. We could see that for baseline attacks, it has high fooling rate to fool the object detectors, but it is very easily to be detected by context consistency checkers. And for our adaptive attacks, it has a high bypass rate to evade the context consistency checks. The bottom plot shows the anomaly score distributions in three scenarios. We could see that for baseline attack, the peak is far away from the benign examples. But in our white box adaptive attacks, the distribution highly overlapped with the benign examples. This is all I like to share. Thank you.